Guys, look at today's topic is exception handling. Okay, exception handling is the most important topic. So for day-to-day, coding purpose, and without this exception handling, it is any language you take, any language, it is impossible to code, right? So before going into the subject, first let us know what is an exception. So you are looking at my screen. What is the exception? The exception means an unwanted, unexpected event that disturbs the normal flow of execution of a program is called an exception, right? So because we don't want the exception is to be raised while we are doing a program, and then that is the unexpected thing. We are not inviting it to happen during the program execution. So that's why we call it as an unwanted, unexpected thing or unexpected event that disturbs the normal flow of execution is called exception. Right? You will see different exceptions that rises during the program execution. And so whatever, there are some predefined exceptions that are already there. So apart from the predefined exceptions, you can also write your own exceptions, right? So we will see, we move on. So what is the meaning of this exception handling? So what is this exception? Exception definition you already know. And what is handling exception? What do you mean by it? So is it so the way of repairing the exception once the exception has occurred? So it is not that. So because there is no question of repairing the exceptions in general. So most of the people feel that so when the exception has occurred, we have to repair or we have to provide some repairing mechanism so to get over this exception situation. But it is not that. So what is this meaning of exception is? So instead of, when the exception has occurred in your program, you have to provide an alternative way to get over the situation. So that is the meaning of exception. You can see here on my screen. So define an alternative way to continue the rest of the program normally. So otherwise, if an exception has occurred in the middle of the program, what is going to happen is your program is going to be terminated abnormally. What do you mean by abnormal termination? For example, I have 10 statements in my program. At statement 5, some exception has occurred. Some unwanted thing or uninvited thing has happened. In that case, what we have to do? So rest of the program will be continued. No, rest of the program is not going to be executed. So no statement thereafter it is going to execute, and the program is going to be terminated. Okay, so that is the thing it is going to happen. Means then my intention is, so though this kind of exception occurred at statement 5, I want to continue the rest of the program. That is the objective. How you can do that? Then you can provide an alternative mechanism to continue the rest of the program execution. So without any disturbance. So this is actually the meaning of exception handling. So it is not that so repairing or providing something extraordinary. So as part of this, it is not that. So what we are supposed to do is, so we have to provide an alternative way to continue the execution of the program. So without terminating abnormally. So your program should always be terminated gracefully. Your program should always be terminated normally. What is normal termination? So all the statements of the program should be executed without any disturbance. That is what normal flow of execution. So because of something, my program is abrupted at some point of time, rest of the program is not going to be executed. That is what abnormal termination. Abnormal termination leads to a lot of things. So underutilization of the resources are the resource utilization is going to be so it's going to be a problem for you. That's why in order to avoid such kind of situations, what we are supposed to do is we have to provide an alternative mechanism so to continue the rest of the program. That is nothing but exception handling, right? Can you see an example here on my screen? So you have a try block. So for example, here you can see capital T. It is not capital T because of this editor. You are seeing the capital T. It's only small t, right? So wherever there is a possibility of raising an exception in your code, so that portion of the code you are supposed to keep inside the try block. Okay, you can see it. Yeah, so here read a data from the file. For example, I have placed a file in some server located in London, right? So if and I want to read the data from that file, for example, right? For example, so the data that I am trying to access is not available there. For example, so it is moved to some other location. Assume now I have kept my data inside some computer. So for some maintenance purpose, they have, I mean, somebody have moved without my knowledge. So my file from that system to other system. So then, so if you are trying, if you are reading that file from by using your program, then definitely an exception is going to occur. It means when the exception has occurred, what you are supposed to do. So if somebody have moved your file from this location, so then what you are supposed to do, you have to provide an alternative way to get out of the situation. So there, what I am doing, yes. So in system one, I have placed all my files and I am trying to read it, but the data somebody has moved from that place. Then I have to provide an alternative way. So if the data is not available in system one, you go to the system two or go to the system 10 and get the data. So that is what the providing an alternative way to continue the rest of the program. Right? Can you see here? Read the data from London file. Means in London I have a server and then I have kept some data inside that. And then if the data is not available in the London file, then you read the data from use the local file to continue the rest of the program. Here you can see continue is a keyword. You cannot just have written some text there. Okay, because of this editor, you are seeing different colors, right? So continue is a keyword in Java. That's why you are seeing that continue. Use the local file instead of using the remote file. Use the local file. That is the alternative. Okay, so this way you can provide it. Now you can see an example here. If you do not have the exception handling, so you can see a program here. No error handling. So you have public static void main and string args, and I have defined two variables here: a is equal to 7 and b is equal to 0. Now, so here I am doing a by b. My a value is 7 and b value is 0. So if I am trying to divide a by b, then what is going to happen? You might be knowing it. It results in arithmetic exception. So then how do you get? So because at that point, what is going to happen? Your program is going to be terminated abnormally. Then that should not happen. Then what should I do? What should I do? I should provide a mechanism. Okay, right here you see. So if the exception has occurred in the system.out.println result is a by b, then the program will not reach the next statement. Right? It means there the execution ends there, and then rest of the statements are going to be skipped by the compiler. So that's if there is an exception handling, this is the thing. This should not happen. This should not happen. There are several problems with that. So if a program is terminated abnormally, you will end up with several kind of problems in the coding. So that's why this should not happen. So you should always provide a graceful termination mechanism for this. Okay, you see, if the exception handling mechanism is enabled, you could see something here, right? So without traditional way of error handling, like see, even I am not using any exception handling here. So there is some kind of checks are here. You can see a is equal to 7 and b is equal to 0. So here I am checking whether b is not equal to 0 or not. If b is equal to not 0, then it is okay. 7 by 0, it is okay. If b is not equal to 0, only you divide so a by b. If it is not that, then you are supposed to provide something. Then in this case, what is going to happen? If condition is going to be true, if the if condition is going to be, if condition is false, then you can divide the number a by b. So otherwise, what you will see, system.out.println b is 0, and then so your rest of the statements are going to be continued. That is the point here. So here you can see program is going to be terminated normally, or program is going to be terminated abnormally. You tell me, guys. My voice is audible to you? Once, can you please tell me, guys? Yeah, thank you. Yeah, so here my program is going to be terminated normally, or it is going to be terminated abnormally. Yes, I am beforehand I am checking whether b is not equal to 0 or not. If b is equal to 0, I should not proceed. If b is 0, then what should I do? I should not do the division. If b is not equal to 0, then only I have to do the division. And these kind of checks I can do programmatically. So if you want to do the, if you don't want to go for without exception handling, but this is even not good. So you have the ready-made kind of thing concept called exception handling. So you can use the exception handling without, without using this traditional error handling mechanism also. Okay. Now you see. So see, a good program should be able to handle these conditions gracefully, right? Right. Java provides a mechanism to handle these errors condition that we call as exceptions. You see how you can do this, right? So if I am writing a program like this, you see my program on the screen here, class test, and in the main, so I am calling what method? So I have two methods here. I have three methods here. So one is the main method. So other method is do stuff method. So one more method is do more stuff method. Okay, there are three methods here. So in the main method, I am invoking do stuff method, which is a static method. Directly I can invoke it because static to static things can be accessed inside the static area. So without object reference directly. So that do stuff I am calling. So in the do stuff method, again I am calling do more stuff method. In the do more stuff, I am doing an exception. Okay, so I'm writing a statement called 10 by 0. Then you tell me. So if you compile this program, what is the exception you are going to get is, so get a test main test.java 4, get a test.do stuff test Java 7, and get a test.do more stuff test.java 10. So exception in thread main java.lang.arithmetic exception divide by 0. So you are going to get the runtime exception if you run this program. What is all this? You can see here. When a program is executed, when you are running the program, what is going to happen is it will maintain a runtime stack. You can see here. First, so whatever the method that is to first method that is to be called in any Java program is the main method. Then it is going to be pushed into the stack generally. So this is the runtime stack. With this concept we call as runtime stack. Why you are getting such kind of errors? I mean, that we call as a stack trace. Stack trace. Okay. Now you see main method is going to be pushed into the stack. Later in the main method you are invoking the do stuff method. That's why do stuff method is going to be pushed into the stack. Next in the do stuff method, you are again invoking the do more stuff method that is also pushed into the stack. Again. So now, so do stuff method is executed. So that is going to be popped up from the stack again. So now the execution of do stuff method will take place. Once it is executed, it is also be placed. I mean, it is also be destroyed or popped from the stack. And then what is the last method that is to be executed? Main method. Once it is done, so then it is going to be everything. I mean, all the entries of the stack, it is going to be destroyed by the JVM. This is what runtime stack. So generally all the method calls during any program is going to be pushed. Method calls are going to be pushed into the stack. So the order of the last top of the stack method is going to be, I mean, last method which is pushed into the stack is going to be executed first, and then recursively it is going to be completed. Last method that is executed is the main method. Because in the main method you are calling the do stuff method, that is pushed. Again in the do stuff you are calling the do more stuff, again that is pushed. Now do more stuff is going to be executed, and then after do more method, do stuff is executed. After do stuff, main method is going to be executed, right? You can see that's why you are getting this kind of stack trace. We call it as a stack trace. First, it is saying that get test.main 4. At 4, we can see what is there. Yeah, do stuff method. So now, so in the do stuff method, what is called do more stuff? That's why it is so main method, do stuff method, and do more stuff method. In this sequence, it is going to display the errors. Java compiler is going to produce or it's going to display the errors. So the main method. First thing, last thing that is to be executed is main method. In the main method, what is the method that is called? Do stuff method. In the do stuff, what is the method that is called? So do more stuff. So this way, this is called as stack trace. When you run this program and then 10 by 0 is there, exception has occurred. When the exception has occurred, then it is going to completely display where the exception because of what it has expected. Right? Instead of displaying only do more stuff 10, it is also displaying the other things like where it was actually called this do more stuff. So do more stuff method in do stuff. Okay, where this is actually called inside the main method. That's why it is also mentioning main method, do stuff method, and do more stuff. This is called as stack trace. Okay, so in the compile, when the exception has occurred, Java compile is going to display you so the stack trace. For example, if you have only one method, it is going to tell you directly that. If we have, so the calling sequence is there for the methods, then it is going to display all the calling sequence of your methods. So this is what we call as stack trace. Okay, you also remember, I'll tell you there is a reason for explaining this. Okay, so the way the Java compile is going to display the message, instead of just mentioning where exception has actually occurred, just to do more stuff instead of displaying that. So it is also displaying its caller methods. Can you see here? Do more stuff is called by do stuff. Do stuff is called by main. That's why it is also displaying the other methods. You remember this, right? Now in the Java, if you look at, the big exception hierarchy is there. First, so how this exception hierarchy? This is most important. You have to remember this. You have to memorize this. Okay. So for any class, the super class is object. Yes. After that, you have a class called throwable class. This throwable class is extending from the object class. Okay. In the throwable class, there are two things. One is exception class and error class. Exception class and error class. In the exception class, so you have few classes like runtime exception class. So and then in the runtime exception, you have several classes. And so in the exception, you have IO exception, SQL exception, servlet exception, a lot of other exceptions are there. It's a big tree is there. We are not mentioning any of that. We are just mentioning only few of that. Okay, so IO exception, SQL exception, servlet exception, a lot of other exceptions. In the IO exception, IO related exceptions will be there. So end of file exception, file not found exception, so interrupted IO exceptions. These exceptions are there. In the SQL exception, so you have a lot of other exceptions which are related to the database connection related things are there. And the servlet exception, when you are trying to connect with the Java web components using servlets, so you will see servlet exception. So such kind of exceptions you will see there. And then other hand, so you have the error mechanisms. So error means you have linkage error, so virtual machine error, so assertion error, verify error, and then out of memory error, and then stack overflow error. Okay, so see, when an exception, there is a difference between exception and error here. The exception means recoverable things. As a programmer or as a developer, so you can recover. You can provide a recovery mechanism, or you can always provide an alternative mechanism if an exception has occurred. But if an error has occurred in the system, so because the errors are going to happen because of the lack of the system resources. For example, so the entire, if you are using stack overflow error, right? Stack overflow means I am calling A method in B. So for example, I have two methods, M1 method and M2 method. I am calling M2 method in M1, M1 method in M2. So because these two are going to be called so repeatedly, then what is going to happen? So the entries are going to be put inside the stack. So at the end, what is going to happen? This entire stack is going to be full. So then what it is going to display? Stack overflow error. You have to take care of this. So as a developer, you have to take sometimes because of not your code. So it is also going to happen stack overflow error because of the limited resources available in the memory. For example, memory also. So you have only the few. So the size of the heap memory is very less, and then size of this other like method area is also less inside the any system, any JVM, right? In that case, if the resources are not available, so if you run your program, then what it is going to display? Out of memory error. So as a programmer, you cannot do anything if you get any such kind of errors. So errors are irrecoverable by you, but whereas the exceptions are recoverable by you, because you can take care of these exceptions that happen in your program by writing some alternative mechanism in your program. But so if the lack of resources are not there, you are not responsible to handle that. So you have to inform this to the system administrator. Yeah, so you can call some person so who is acting as an administrator in your office, and then you can ask him what is this error? I am getting verify error. So maybe JVM is not properly functioning. So sometimes you'll get the linkage error. So sometimes you'll get assertion errors, virtual memory errors. These errors are there. So for these you are not responsible. Your administrator will take care of this. It means that's why we say errors are recoverable, whereas exceptions are recoverable. Right? For example, arithmetic exception has occurred, then I can take care of that. Null pointer exception has occurred because maybe you are referring to a null kind of thing when you are, I mean, on the null object you are trying to invoke something, some method. In that case, you will get a null pointer exception. Index out of bounds exception. Index out of bounds exception. There are two type variants in this: array index out of bounds exception and string index out of bounds exception. Array index out of bounds exception. If you are trying to access any so the index which is not available, for example, I have declared an array of 10 locations, and whereas if you try to access 12th locations or 13th location, whatever it is, which is outside, then you will get the array index out of bounds exception. Remember, array index out of bounds, right? A capital, I capital, O capital, B capital, and E capital. String index out of bounds exception, when you are trying to access the same index, so because the string is 0-based index, right? So array is also 0-based index, right? So for I have 10 characters in my string. So if you are trying to access 11th character, then I am going to get what? Array index out of bounds exception. There is no array buffer index out of bounds indexing, right? Because arrays are going to be string buffer index out of bounds exceptions are not there. Remember, string buffers also string objects only. That's why illegal argument exception. In the illegal argument exception, you have the number format exception. For example, I already told you that day. So again, I will show you here, right? For example, so in the integer I is equal to new integer of, you can provide a string value or you can provide a primitive value there. So right, but whatever the value that you are providing in the form of string is not possible, you are going to get the number format exception. That I will show you here. Next, so class cast exception. So if the classes are not castable, right? If you are trying to create, trying to cast a student object into customer object, its casting is not possible. So when the casting is possible, if there is a relation between superclass and main, if there is a inheritance relation from so the superclass object to child class object, then only I can cast it. So the other kind of where different heterogeneous object casting is not possible. And illegal state exception. So this variant generally used in the threads. When the thread is in already running state, when once again if you say please start, then inside such kind of situations, when the already thread in the running state, so and once again if you say that please go to the active state and so on, such kind of things are illegal state exceptions. And then file related exceptions will be there, and then all these kind of exceptions. For every topic, for every concept that we see in Java, you have the bundle, lot of exception classes or predefined exception classes are available. For example, you take, so runtime exceptions or normal exceptions are very mostly used exceptions are there inside the runtime exception category. And then IO exception, IO related. So next I am dealing with the SQL. So there is the SQL exception. Java servlets, and JSP exceptions will be there. Remote exceptions will be there. So for all the Java modules, you have the different exceptions are there. You try to remember this diagram is enough, and you can also put ... notations there, and you need not provide anything. Okay. So and then you please try to have this in mind so that so for better understanding. Okay. Right. So the commonly used exceptions you can see here. Okay. Yeah, these are so this already explained you. So general arithmetic exception, array index out of bounds exception, you already know. Array store exception. So array store exceptions means array store exception we will see like negative size index. We will see this. We will see array store exception with the program. We will see this. File not found exception, you already know. File, so which is whatever the file that you are trying to locate is not available, you will get this. And then IO exception. So usually the IO failure, and the null pointer exception, reference to a null object. Out of memory exception, and then security exception. So these are used in the security in the browsers and all. So these are the common Java exceptions. Okay. Now you see, we'll go into the exception mechanism. How actually we can do this by using the code here, right? So see here. So what is the try block? So try is a keyword I already told you. So um, so if there is a possibility of raising exception, so you have to identify that code portions in your program. No, assume I identified there is a possibility of raising exception at location. I'm sorry, in line 5. Then what I'm supposed to do is that line 5 is to be kept in the try block. Okay, unnecessarily we should not provide. We should not put in the try block. So there is a problem. There might be a problem, or there may be a problem if we guess. For example, if I am writing file related code somewhere in my program, like from line 4, 5, 6. Okay, line 4, line 5, and line 6. I have written 3 statements which are related to IO. So definitely, if there is an IO event, IO exception, there is a possibility of raising IO exceptions there. Means, for example, I am trying to create a file. So I'm trying to referring to a file which is already available. So I guess that that file is available in that location. For example, C colon ABC folder, and then the file is xyz.abc. So I am trying to access that file, but that file is not there. Then what is the exception that you are going to get? File not found exception you are going to get. Yeah, such statements. Whether I am going to get the file not found exception or not doesn't matter for me. So I am sure that the file is available in the C folder ABC directory. So what I am supposed to do is, yes, there. I mean, so for now it is there. In the future, somebody may move that file to some other location. Keeping those things in mind, what I do is I just keep that file in the try block. Okay, wherever there is a possibility of raising exception, either now or in future, that code portion I keep in the try block. Okay, and after that, immediately I write the catch block. Okay, in the catch block, so I provide the alternative methods. Okay, so wherever there is a possibility of raising exception, that code portion I have to keep inside the try block. So later, so immediately after that, without no statement you have to write after that. So immediately what you are supposed to provide? Catch block. So statements that handle the exception, you can write it. Or so the statements that statements that gives you the alternative way of handling the alternative way of continuing the program will be written inside the catch. Okay, always the exception handling I told you now, we have to always give an alternative way of running your program without any disturbance. That you have to provide in the catch block. Okay, so here you see. Here is an example. So if I write a simple program like this, so class test, public static void main string args, and then I have written a statement 1, and system.out.println 10 by 0. And after that, I have written one more statement, system.out.println system 3, say statement 3. Now, so if I compile this, what is the output I am going to get? So output I am going to get is, there is no problem with the statement 1. So system.out.println statement 1 is going to be executed, statement 1. After that, so because of the statement system.out.println 10 by 0, so exception has occurred. Right, exception has occurred. Can you see this? Any pointer here? Yes. Yeah, you can see here. At this point, exception has occurred. Then what is going to happen? So it is not going to, because the exception, unexpected thing has occurred in this line. So it is not going to execute the statement 3. So then, so it is saying it at the test.main, it is going to display. And then what is the error? RE dot. So next it is going to tell you, so by divide by 0 error, it is going to display. And where the divide by 0 error has occurred, it is also going to display, so the method name, yet test.main. In the test.main, so an exception has occurred. That exception name is what? Divide by 0. and after that your program is going to be terminated abnormally. So the abnormal termination should not take place. My total objective is that my program should not be so terminated abnormally. That is my final objective. The total objective of using exception mechanism or exception handling is, okay, so only to provide the graceful termination for your program. All the statements of your program should be executed without terminating abruptly. That is my goal here. So here you see. So if the exception handling is provided, yes, there is a win for the statement one. I don't think that it is going to raise any problem. No safe, and then you come here this position. Yeah, this statement may raise an exception because you are doing some arithmetic operation here. I don't know. I assume that I am not intentionally writing 10 by 0. You are writing a comma b and you are doing a lot of operations on a and b, addition, subtraction, finally you are dividing. And in this case, there is a possibility of raising exception. So that's why you have to keep what? So you have to keep in the try block. Okay. So risky code. Wherever you feel this code is risky, yes, that you put inside the try block. And you provide a catch handler, and there, so arithmetic exception. What is the exception that is going to be raised in this code? That exception you write in the catch block. And you see there should not be any statement in between this and that. Now after try, immediately where you have to write, so you have to write the catch block without any statement in between. You are not supposed to write any statement. Yes, you already know that. And inside the catch block, so what I am doing it, I am providing the alternative mechanism system.out.println 10 by 2. Yes. So immediately when the try block is executed, yes, exception has occurred. So that immediately, so the compiler looks whether this has given any catch handler or not. Yes, there is a catch handler. Immediately it jumps into the catch handler and it is going to execute this statement. Okay, 10 by 2. This statement is going to be executed, and so after that it will come to the next statement. Right, you can see system.out.println system. Yeah, this is also going to be executed. All the statements of your program is going to be executed so that it is normal termination. Right, now you can see, so the statement 1 is executed. Here in the left side you can see statement 1 is executed. 10 by 0 there is an error. Yes, it looks for whether this guy has provided any handler or not. No handler, so immediately what the program is going to be terminated abnormally. Yes, this in this case it is abnormal termination. In this case it is normal termination. Yes, or graceful termination. Now here, so handler is provided. That is the difference between having the without the catch block, or not having the exception handling, and this is having the exception handling. Now you see, and simple thing with respect to this program, you tell me. Now you understood what is abnormal termination and what is normal termination. Normal termination means all the statements must be executed. Okay, if all the statements of your program are executed till the end, if it reaches the end of the program, then it is okay. Otherwise it is abnormal termination. You see that? Assume, so statement 1, statement 2, statement 3 are there. So and then I feel that there is a problem with this code. Statement 1, it may raise an exception, and my statement 2 also, may raise the exception, and then my statement 3 also may raise the exception. So that's why, so catch handler I am providing. Okay, assume that, so all these are the same kind of exceptions, where all this code so may raise the same kind of exceptions. Okay, in that case I am writing the catch handler immediately, and then I am providing this in this case. Now you tell me, there are 4 cases here, you tell me with respect to this. Yeah, so in the case 1, so there is no exception, right? So you are thinking that there is an exception and you have kept this code inside the try block, and so you assume that there is no exception. What is going to happen? So all the statements in the try block are going to be executed. So it means the statement 1 is going to be executed, statement 2 is going to be executed, statement 3 is going to be executed. Now, so there is no need of executing this catch handler because exception has not been raised. Because there is no exception in your program now. That's why you need not worry about catch handler. When there is an exception, okay, raised inside the try block, immediately it is going to look for the catch handler. But there is no exception. We assumed that there is no exception in the try block. That's why it will not come into this. Then, so whether this will come The statement 5 is executed, yes. Now that's why, so 1 is executed, 2 is executed, 3 is executed, and the statement 4 will not be executed. And then 5 is going to be executed, yes, 5 is going to be executed. And so it is normal termination only. Because exception has not raised, there is no problem at all. Now you see the case 2, if the exception raised at the statement 2, exception raised at the statement 2, and the corresponding catch block is matched. Corresponding catch block is matched. You can have different catch blocks that I will show you. So assume that the corresponding catch block is matched. Assume, yeah, here statement 2. So there is no problem for the statement 1 that is going to be executed. And then case, this is raised. So the statement 2 raises an exception. So and the corresponding handler is found. Assume. Then what is the output? You tell me. Yeah, there is no problem at 1 that is going to be executed. So the exception raised at statement 2, so the statement 2 is not even, so it is not going to be printed, and the rest of the statements are not going to be continued. You tell me, if exception occurred at statement 2, whether statement 3 is going to be executed or not. Statement 3 is not going to be executed. From that point, directly it jumps into the corresponding catch handler. Okay, it is not going to execute any statements after that. Wherever the exception has occurred, from that point, directly it jumps into this code. Okay, now you can see, yeah, statement 4 is going to be executed, and the exception has caught or not. Yes, exception has already caught. That's why there is no problem at all. It is going to execute statement 5 also. Now you tell me, so if there is an exception at statement 2, so what is the output? So the statement 1, and then, so now it will directly come to the 4, and then 5. 1, 4, 5, it is going to print. Assume there is another situation. Assume there is another situation. So exception is raised at this statement 2, and but the corresponding catch handler is not matched. Then what is going to happen? You tell me. The statement 2, exception has occurred, and there is no the appropriate handler to handle that. Though we have provided this catch handler, but the catch handler provided is not suitable to handle the statement 2 exception. In that case, what is going to happen? So assume, so 1 is going to be executed, and here the exception has occurred. Immediately it will look for the respective catch handler. Yes, there is no catch handler for that. This catch handler is not suitable. So that's why immediately what is going to happen? The statement 5 is not going to be executed. So it is going to be terminated abnormally. You can see this. If an exception raised at statement 2, but the corresponding catch block is not matched. So what is going to happen? 1 is the output, and followed by abnormal termination of the program. If catch handler is not provided, if proper catch handler is not provided, always it is abnormal termination. You remember this point. If catch handler is appropriate, catch handler is provided, yes, it is always normal termination. It means rest of the program is going to be continued without any problem. Yes. So the appropriate catch handler is not found, rest of the program is not going to be continued. Program is going to be terminated always. Assume that an exception is raised at statement 4. You see here, statement 1 there is no problem. Statement 2 there is no problem. Statement 3 there is no problem. And statement 4, yeah, there is a problem. Yeah, there may be problem, right? So I thought of providing an alternative mechanism inside the catch handler. So even that code may raise the exception, right? So in that case, because I did not mention any catch handler for that, in that case, what is going to happen? So the program is going to be terminated abnormally. Okay. So in that case, so the statement 5 is going to be executed or not? It's not going to be executed because it is always abnormal termination. You see, next topic is, so the multiple catch statements. So why do we need to have the multiple catch statements in your program? So you see here, so try block I have given in my code. So here you can see. Here you can see. Can you see the pointer, ma? Can you please tell me whether my pointer is available? Can you see this? Yeah, can you see the red tick mark here?
Yes, sir.
Yeah. So you see the try code is there. Inside my try code, assume that there are 10 statements or 20 statements. Okay. So each line of the code may raise different exception. You see here. So I am going to write several lines of code here. So here, okay. So this is my try statement. This is my try statement. So in this case, assume this first line may rise, file not found exception. The second line may rise arithmetic for exception. The third line may rise the SQL exception. So the fourth line may rise the remote exception. The fifth line may rise again null pointer exception, number format exception. I have written 10 lines. There is all the 10 lines are different lines, and each line may rise some exception. So first line, one exception, second line, one more exception. So different exceptions may be raised. In that case, what we are supposed to do is, I should provide catch handler for all those exceptions. For example, so first statement, you have to write a handler. Second statement, you have to write a handler. Third statement, you have to write a handle. Only one handler is not sufficient to handle all the exceptions. Remember this point. So in this case, what you are supposed to do, you have to write the different exception. Some people write, there is a simple trick to get out the situation. Instead of writing all the exceptions, people try to write the exception, but it is not acceptable code in the code review that will be thrown. Okay, remember? So you have to provide a different catch handler. So for each kind of exception that may rise inside your try code, remember always this. In the try block, so if there are 10 lines, all the 10 lines may rise 10 different exceptions. In that case, you have to provide 10 catch handler. This point you remember, right? And so various method to print the exception information. Yes, okay. So abnormal termination may happen sometimes. In that case, so what kind of exception has actually been raised? So in that case, if you want to know that information, because of what thing the exception has raised, if you want to know that information, so you can always write, you can always use these methods. There are 3 methods. For example, e.print stack trace. For example, E is my exception object. E.print stack trace means what? So stack trace I already told you now. So first you tell me where the exception has raised, and next where it was creeped into, and next again, so where it was creeped into. That entire stack trace means, so for example, so in the main method do stuff is called, in the do more stuff is called. So in the do more stuff the exception has occurred. Then it is going to display you. So first do more stuff, next do stuff, and then so main method. So that is what stack it is going to display. So if you want that information to be displayed, so such kind of information, detailed information, if you want to be displayed, so you have to use a method called print stack trace. And no, I don't want this much information. I just a brief description, very brief description of the exception. Then in that case, exception, a name of the exception followed by small description. If you want, you can use toString method. toString method. So otherwise, so if you want, so the very small description, I don't want the name of the exception also. So because of what thing the exception has raised, very small description if you want to see, you can use the method called getMessage method. There are 3 methods to print the exception information. One is print stack trace, and then toString method, so getMessage method. If you don't use any of these methods, so and the exception has occurred in your program, by default JVM is going to display, JVM is going to use this print stack method to display the information. Okay, remember. So if you are not doing anything and not aware of these methods, JVM will use print stack trace method to display the information to you. Otherwise, you can also write in your program in the as part of exception handling. Okay. Now you see this. So all these methods you can see this. Test class is there. So inside this you have a main method, and so I feel that there is a possibility of writing arithmetic exception. Standard out at println 10/0. So that's why I kept this code inside the try block, and I want to provide a catch mechanism, catch arithmetic exception. So you have to use name of the exception. This is actually the predefined class which is already there. This arithmetic exception is the predefined class, and so you create this. Who is going to create all this? That's not your job. JVM is going to create the exception object. When the exception has occurred in your program, immediately it is going to create the respective object. So that you mention here. You just mention the name of the exception that is going to happen here. but the responsibility of creating the arithmetic exception object lies with the compiler only, I mean JVM only, right? So yes, exception has occurred. Yes, e dot print stack trace. So what is that? If you want to know the detailed information, java.lang.arithmetic exception divide by 0 at test.main test.java colon 6 at 6th line in the main method. So the exception name is what? So this is divide by 0 and then the respective class is arithmetic exception, which is available in java.lang package. And you see system.out.println, just you say e means it is going to invoke. If you are trying to print any object directly, what is object reference? So what it is going to do is it is going to invoke toString method on it by default. Otherwise you can also write e.toString. So what is the information you can see here? Java.lang.arithmetic exception divide by 0. Where exactly the exception has occurred, it is not going to mention. So otherwise, no, it is not mentioning where exactly in the main method in the line 6, all this information it is discarding if you use e.toString method. Okay, e means e.toString only. Okay, if you don't mention, it is going to put it toString method. Right, e.getMessage, it is very nice way of displaying the information. No more details are required, only divide by 0 information I got. In that case, what you can do is e.getMessage. So what are the methods that are used to print the exception information in Java? There are 3. One is print stack trace, other is the toString method, the third one is getMessage method. Okay, so difference you can understand from this. So this is right, and it is 12:09. Okay, now you see. And there is one more important block. Apart from, you have already seen to the respective to the exception handling, you have seen 2 keywords. No, that T is not capital T. Remember, while copied and from the edit plus, it has become capital T. No, you always use small t only. So try inside the. I have kept my risky code inside the try block, and then respective handler I have provided. Yes. Respective handler I have provided here. So now, so after that, you can also mention a block called finally block. You remember, see? So another finally here. So what is the purpose of finally block? So here, you can always write this finally block. The purpose of finally block is, so anyway, you have some risky code you have written in your program. So because it is a risky code, exception is raised. And if the exception is raised, immediately it will go to the catch handler. Yes, the catch handler, you are going to provide the some handling code there. Yes, anyway, your program is going to be terminated. Anyway, your program is going to be terminated abnormally. So then what I am supposed to do is, whether your catch handler is proper or not, I am not sure about it. In that case, it is better to have a finally code where we are going to write the cleanup code. Cleanup code means, for example, so you have opened several connections in the try block. For example, file f is equal to new file of some abc.txt. So you have opened a file, and then so database connection. So connection con is equal. So the connection con equal. What is the code that you have to write to get the connection object? You got the connection object. So connection con equal. What is the code? Statement dot. So what is the code we have to write? Assume that you got the connection code there. So you have opened the database connection, and then several of these kind of things you have already done in your risky code. Means, for example, one is you have opened 10 files and you have opened some 10 database connections. In that case, when my program is going to be terminated abnormally, what about these connections? So those connections are going to be persist. So those are going to become open connections only. Right. For example, assume that I have only my server is accepting only 10 database connections. Now it can give only maximum limit is there in my database connection. That is 10. Assume. So all 10 connections are already over inside my risky code. But so in that case, what is going to happen? Your program is going to be terminated abnormally. In that case, all the open connections are going to be intact. It means, so those cannot be closed. For example, 11th person came to establish the database connection. In that case, will this person will get the connection object? No, because so the maximum limit of the connection objects is 10, and then the 11th person is requesting for the connection object, because all the objects are now open in the open state. Unless you close those database connections, you will not get any database connection. Yes, further any database connections are not possible. Right. For that case, what you are doing is, so whatever the codes, I mean, whatever the connections that are open, whatever the files that are to be open, is must be closed before terminating your program. Anyway, your program is going to be terminated abnormally. If the program is going to be terminated abnormally, what is going to happen? So those who want to connect your database, they cannot connect because the connections are open and your program is terminated abnormally. In that case, so no other person is going to establish the connection in the database, right? Because there is a limit on the resources. No, resources are not going to be unlimited. For example, how many files I can open in my code? For example, how many files you can open in a any C language or C++ or Java program? There is a limitation on that. Okay, how many? I mean, how many statements I can write? How many files I can open? F open statement is there now. F open statements. How many I can write in a C program or Java program? There is a limitation on that. You cannot write as many as you want. Okay, because there is a limit. For example, it is something like some 1024 connections you can open in C language, or you can also, I mean, in the same for the Windows. So number of files that you can open at max is going to be 1024. Beyond 1025th connection, if somebody wants to open up as part of his application development, then so your file open is going to be failed. Okay, now the file open is going to be never fail. So if you generally, because we are not going to use those many file objects, I mean file connections, you are not going to open those many, right? So because of because the number of resources in the system are limited, it is always mandatory to close the open connections. So such kind of open connections should be closed somewhere in your program. For that purpose, they have given one block called finally block. What you will write inside the finally block is, so you are going to close the connections inside that. Okay, so that is what the purpose of finally block. So anyway, when your program is going to be terminated abnormally, whatever the file connections that are open, whatever the database connections that are open, so must be closed before exiting your program, right? So for the use by the others. Otherwise, what it is going to be? So it is going to be in the open state only. So because all the time, if somebody tries for the database connection, so his code is going to fail. If somebody tries to open a file, so that file statement is going to fail. It is going to return -1. Why? When the connection, if the file is not able to open, so then it is going to return -1. In the same way that is going to happen here also. Right. For example, whatever the connections that are open must be closed inside your code itself. Where I am going to do that? So inside a block called finally block, whether exception has occurred or the exception is not occurred, this finally block is going to be executed always. Remember this point. So here my risky code is there. I have opened several connections, and then so it is the responsibility of the programmer to close those connections. Where I can close this connection, whether exception happened or not. So whether exception happened or not happened doesn't matter for me. Those must be closed. There should be some place designated for that purpose. That is what finally block. Okay. There what we are supposed to write is all coming open connections must be closed inside finally block, so that it is always safe, because so others can happily use the resources. Okay. So this finally block is going to be executed whether exception has occurred or not occurred. In all the situations, it is going to be executed. You can make use of this facility for closing the database connections or file connections. Okay, that's what we call it as cleanup code. Cleanup activities you can write inside the finally block. Remember this point. Okay, what is the purpose of finally block? So why they have provided this finally block? So finally block is basically used to perform the cleanup activities in your program. What is the cleanup activities? Cleanup activity means I have opened several files in my program. Yes, my program is terminated normally. There is no problem. If the program is terminated abnormally, then there would be a problem to you. Like, so 100, I mean, there is a limitation on the number of resources in your system. So in order to facilitate or give chance for others to create their own database connection or files, then so the finally block must be there to write the cleanup code. Means you are going to close all the connections that are open in your program. I think guys you got this concept. Finally block is going to be executed always whether exception has occurred or exception has not occurred. You remember this point. Yeah, you see this. There is an example here, class test. Inside my main method, so there is a possibility of raising exception. That's why I have kept my try code inside. Yeah, so here. Yeah, you can see here. Yeah, so my try code is this. My try code. Yes, assume that there is an arithmetic exception there. Yes, so I am providing a handler here. And so I am going to provide the finally block. If I execute this program, what is the output I am going to get is first in the try block. So what is there? System.out.println try block executed. That is going to be there. So that is going to be printed again. So what is going to done? So the anyway the catch block is not going to be executed, right? So because there is no exception at this point. So and then you can see finally block is going to be executed. Finally block is going to be executed. Yes. If there is no exception, what is going to be done? If there is no exception, so the catch handler is not going to be executed. And then, but the finally block is executed always. Yes, that's why you are seeing the results. Try block executed, finally block executed. Remember, so whether exception occurred or not occurred, the finally block is going to be executed. Right? You see this. You write the cleanup code. You will write this. This is the explanation for that. Why finally block? Remember, why finally block? To perform the cleanup activities. What is the need of performing cleanup activities? Yes, I should give the facility. I mean, facility or I can give the chance for others to create their own the open to files. Okay, R connections. Remember, right? Time. It's already 12:20, so we can close now. Tomorrow we will see the rest of the exception handling. How can you? Let us take attendance. So here the 66 members means 64 members are present. So quickly let me take the attendance. You also provide your roll number in the chat box. Ma, also provide your roll number in the chat box, ma. Yeah, roll number 1832.
Present, sir.
121, 121.
Present, sir.
1.
Present, sir.
2.
Present,
3.
sir.
3.
Present, sir.
4.
Present, sir.
5. 5.
Present, sir. 5.
6. 6.
Present, sir.
7.
7 present, sir.
8. 8, ma. Roll number 8. Nikita. 9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12. Roll number 12, Ritika.
Sir, 12 having mic problems, sir. She put it in the chat box.
Okay, ma. Okay. No problem. So 13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Sir, 16, she put it in the chat box, sir.
Okay, ma, I will check it. Okay. So 17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20. Roll number 21. 21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
26.
Present, sir.
27.
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33, 33 ma? Bhuvaneshwar? Oh, Bhuvanesh is
Present, sir.
absent.
33.
Okay, Bhuvaneshwar. Bhuvaneshwar, you did not come in the morning class. Morning lab, you did not come, right?
Yes, sir. I couldn't.
Okay. 34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
41, 42,
42 present, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49, 49,
Present, sir.
50,
sir.
50, 51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57, 57 ma?
Present.
58,
Present, sir.
59,
Present, sir.
181, 181 ma? Ashish, 182,
Present, sir.
183, sorry, 301,
Present, sir.
302, 302 ma? 302. Oh, she's absent. 303,
Present, sir.
304,
Present, sir.
305,
Present, sir.
306.
Present, sir.
Absent is చూస్తున్నాను చూడండి అమ్మా 8 absent అండ్ 8 తర్వాత సో 181 absent అండ్ నెక్స్ట్ 302 absent అమ్మా 3 members 302 absent కదా షీ ఈస్ నాట్ దేర్ 3 absent యా యూ కెన్ లీవ్ నౌ